in order to build anything that we use as a group, civil engineering, the word civil society is right there in the mix of it. So civil engineering is all about building cities and counties, everything, all that interconnection that we have. Anything that we use as an entire group is, designed by and supervised, everything like that with civil engineers. Let's see. So here's a quick definition that you could get down in your notes, at least to have like a single definition there, similar to what I showed you before. But civil engineers, they're designers. They're a part of the construction process, not like with their hands, building it, but they're part of the construction process as they supervise it and work with all the operations. And that could be large projects to small projects, big cities to small cities, any sort of system that the public uses together, like all the roads that we use, public buildings, airports and tunnels, dams and bridges, anything that has to do with our water supply to our houses and our businesses, to the sewage that we pull out of them. All of that is worked on and designed and implemented and maintained through civil engineering. It involves a lot of design and work, and civil engineering is a key component to all of that. It does involve having a bachelor's degree, and it does involve a license system. I had actually started this process myself. I went to school to be an mechanical engineer, but when I went into teaching, before I went into teaching and after getting out of college, the in-between time, I did civil for a year and a half and worked at 2 companies. The reason why I wasn't doing it is at the time there was a economic recession. So it was kind of hard for the people with the least experience to hold on to their jobs. So I decided to do teaching math. In the meantime, wasn't sure if that was a long-term goal for me or not, but my sister used to do elementary school teaching, and she said, why don't you try teaching math at high school or something like that? Yeah, I'll give it a shot. So I just decided to stick with it, decided I for the most part really liked it. I like doing teaching, so I really loved the opportunity when I got to do teaching engineering and teach what I learned in college and on the job and so forth. So it was a great opportunity to be able to mix together a newfound interest of teaching, teaching students and my passion of engineering. So it was good to be able to mix those together. Civil engineers do all types of things. Like they work really close with surveyors. Surveyors go out and there's a license for that too, registered surveyors. They go out and they analyze what the land looks like right now. That is the topographic information, like heights from sea level. We use a lot of satellites for that now. That is, existing. Is there any sidewalks? Where are the pipes location? Where is there a fire hydrant? Where's the lines? Is there any existing buildings or what's out there? So they'll go out and they'll analyze that and bring pictures and all this topographical information, upload it onto a computer, and then the engineer uses that to build a site map of what it looks like now and start building on it to what we propose to do to it. How should we grade the land? Where's the building going to be? Where's the road going to be? Where are the pipes going to extend from? Where do we store water when it rains? All that type of stuff. They do all types of cost of estimation for the construction. As you're building, you got to know how much it's going to cost to do it. So it's something that has to be calculated. So civil engineers usually have a pretty extensive database of how much things cost nowadays, especially since they're doing all different types of projects. They're kind of up to date on a lot of that type of, how much certain materials cost and how much it costs to dig per like cubic yard and fill back per cubic yard, that type of stuff. And area of a road, how much it costs, per like length of road. So they know a lot of this information and can estimate how much it will cost. It even has environmental involved and ecosystems and environmental science and working with permits, local, state, federal agencies. A lot of local governments want the places to have some cohesive look, some consistency, like the same type of lights, the same type of street signs, the same kind of street markers, the same kind of standards for the way the roads look in general ways, and same color like fire hydrants. Like in Harlingen, I think they typically use like a red or yellow. In McAllen, they look totally different. It was like green with a silver cap or some or silver with a green cap. I forget because I used to live in McAllen. So they pick like things like that, and they want some consistency across the board. I know like in federal, they have ADA, which is the American Disabilities Act. Civil engineers build anything that the public is supposed to have access to. So if you're going to build like a courthouse or a school or a city hall, and there's steps going into it, there has to be a ramp for people who can't go up steps, people in wheelchairs or injured, and that type of thing. That your public has to have access to it. So that's why when a school is more than two stories, there has to be an elevator. And even though nobody uses the elevator, if someone is maybe they got hurt and they're in crutches, then they give them a key so they can use the elevator, because we can't deny access to our public goods because it's all something that we share together. Even testing stuff, like a scientist, testing building materials. They use design software like Onshape, we do, but usually tend to be more 2D. It's like an overview kind of map. Oversee construction projects, and they maintain existing public infrastructure. So if maybe a hurricane comes by and damages some areas, and then the engineers may be called on board to, come up with a repair to strengthen it for the next hurricane. So what I want to do is list off a lot of different careers, several career paths under civil engineering. And to be honest, if you like engineering and you like math and you like science, and you like to be outside, civil engineering is a really good fit for a lot of people, because you're going to be outside a lot depending on what you choose, especially like construction engineers. They maintain the construction of the projects, they manage it. Not like they are telling people what to do and they're in charge of a team, but generally they're on site to make sure that things are being done correctly, to schedule, and the correct materials were purchased and the correct dimensions are there in place. So they'll often go out and inspect. If you work for a smaller company, you may do some construction engineering, you may do some of the stuff designing in the office. If you work for a larger company, you might just do one thing. You might be the guy who goes out and inspects stuff all the time, and that's like your main job. So it can be anything that's being built outdoors for the public use, highways and bridges and airports, even large buildings. They do less design work. So if it's a larger company, it's less about designing it yourself, but rather how it's supposed to be built, how to read the plans. Maybe you've been a part of the process of that. But your job is mainly to make sure that things are done correctly. So I really suggest for those that kind of like engineering, but they also can't see themselves doing a desk job, it's a good fit. It is a really good fit. Here, this is like whenever, like I said, knowing different types of laws. That right there is so that if the land were to collapse, no one would get buried alive. So after a certain amount of feet under, it's like 4 or 5 or 6 feet of digging a hole for putting piping and stuff like that, you have to put these kind of support walls so that, if it were to have like a little landslide, the people in there would not get, buried, because it's real dangerous. So, there's a lot of safety stuff like that. Large projects like this might have a construction engineer there on site all the time to inspect and make sure everything is being done correctly. Geotechnical engineers are often outside too. They focus on how structures are like how they interact with the ground itself, the earth. If you're going to go out and build something, different soils work differently. If I want to go out and build a sidewalk, doesn't really matter the ground underneath as much. But if I'm going to put, a building that's several stories tall, or a roadway, that requires different types of earth underneath it. And so you want to have them come out and drill cores, like in that picture there, and try to determine, what type of ground is there. Do we need to add in? Usually you do. You need to add something to it. It's real common to add like caliche to it in order to kind of stiffen it up. Use different other types of earth materials in order to try and get it to a certain hardness level, and they even look at the acidity of it to build on top of. So they go outside a lot too. Even when they go out and the concrete is very different from a sidewalk to, like, let's say, to a dam or to a building. The concrete is different at those different times. So whenever you pour concrete, you're supposed to have a geotechnical engineer have the cement truck pour a couple of samples in like little tin can things, and they test those samples. They'll test them as soon as it's like rock solid, which might be in about 24 hours. They'll test it, then they'll wait another 7 days, because concrete, actually, the longer it sits, it cures it harder and harder and harder. So then they'll test it at 7 days, and usually I think they test it again a month later. Anyways, they can tell real quick on the first test if the concrete was the right level of that we need. So if you're pouring for like a dam or something and it's too weak, they're gonna have to rip it all out. So they need to know if it's the right type of concrete, and not know that when a huge storm comes in and blows it out, or it just falls and breaks due to normal wear and tear. So you have to have that type of stuff tested. Structure engineers, they be a little bit more indoors, but they'll be usually on the higher end of education, sometimes a master's even. And you're talking about larger structures, maybe for bridges or large dams or buildings, talking about number of pillars and how the rebar should be shaped and type of concrete called out and how many pillars are needed and so forth like that. So that would be structure engineering. Environmental engineering, so if you're interested in the protection of the environment, this level is getting a little bit closer to more like scientist, chemists. A lot of counties or cities might have someone. If it's a large city, might have someone or a small team of people that do environmental stuff. You need to know the quality of your water in different areas, quality of your soil, air quality, in order to find out if there's any sort of leaching of certain dangerous chemicals, or like red tide when we have in the at the beach. They'll send like an environmental scientist or an engineer out there to test it, to try and estimate how long the red tide is going to be lasting, because that's a lot of money when there's red tide out at the beach and they close it down. I don't know if you've ever been to the beach when it's red tide, but I mean, the last time it was red tide, I went out there, I wasn't even in the water, and my eyes were burning back at the hotel. So it's pretty nasty stuff. And that's just natural red algae blooms. But, environmental scientists can make those tests and find out how long are we with this plight. All types of things, looking for heavy metal in soil and making sure that the landfill isn't leaking, and all types of different things that they'll do. So this is a little bit more on the edge of like scientists, chemists, still under the branch of engineering. A little bit newer compared to it, being that civil engineering is probably the oldest engineering profession, is as long as you had a society being built, you needed someone to engineer its directions. Transportation engineering, this is talking about flow of traffic, size of roads, everything to do with the road systems. Maybe in a smaller town like ours, we wouldn't have like a dedicated transportation engineer. But in the larger towns, like Dallas or Houston, San Antonio, maybe even Corpus, they might have someone in charge of all that. What if you've ever driven on the road and you drive over like black cables? Those cables are counting how many wheels are driving on the road and at what time. And they collect that kind of data and use it to determine, this road is 2 lanes. Does it need to be 4 lanes? Do we need to have a dedicated turn lane? And you're looking at what your population is now, but also where your population is going to grow. Because you don't always build for where you are now, you build for where you will be, and kind of develop that way. You don't want to have, a city build a road and say, all right, we're going to put 5 lanes going through here, a turning lane and 2 on each side. And then it doesn't really get used that often, enough to justify the cost of 5 lanes. So you would want to have a transportation engineer being able to determine that type of stuff. They also get involved in the timing of lights and pressure sensors for the lights, and location of stop signs and everything dealing with the traffic. A lot of times, like I said, it's really more about like the larger cities where you have like massive interstate interchanges or public transit, subways, rails, that type of stuff. Here, I've got a short video here we're almost done with what I was going over. Last part is with civil engineering, because this is something that the public has to put their trust in, that they can, you know, drive on the roads and live near dams and drive across a bridge and go into buildings that everybody uses. There has to be a certain level of trust from the public. So there is a licensing system that you have to go through. I had started the process, like I had mentioned before. Once before I graduated, I was required by the school I was at, UTPA, which is now UTRGV, to take a class to prepare for that test. When I practiced the test, I got like a 36 on it. And this is a hard test, guys. It's an 8-hour test. So I, you know, practiced as much as I could on the stuff that I missed to try and learn what I didn't understand. Some of the stuff that was on the test, I hadn't even taken the class for yet. But you know, you lean to the strengths that you know that you already have. So I challenged the test at the end of, near the end of that course. It was like over $100 to maybe it was $150 to take the test, and it was an 8-hour test. It's like the first 4 hours, it was like 2 minutes per question. And then you had like an hour lunch, and then you came back and you took another 4-hour section. It was like 4 minutes per question. They were more challenging, so you had less of them, but more time to do them. It was a tough test, and you know, it doesn't come with a formula sheet. They gave us a formula booklet, you know, a small booklet just full of formulas and charts and information. So I actually borrowed one from another engineer that had already taken the test and kind of had an idea of where things were located, so I wouldn't spend forever looking for things. So I challenged it and I passed. I got like a 75, I think. My friend got a 76, so he's like, ah. So, but it doesn't matter. As long as you take the test and pass it, then you get your licensing. And it's the test is called FE, Fundamentals Exam, and then your license is called an EIT, Engineer in Training. And from that point, once you're an EIT, then you can work for 5 years under a professional engineer or multiple engineers, different companies, depending on how you run your career. And for 5 years, you're training under them, learning from those who already are ahead of you. Sort of, you know, like an apprenticeship, but you're paid. You know, you're paid full benefits. It's a real career. It's not like an internship where it's maybe you're not going to get paid. So it's a full-fledged career. With the option that you could become a professional engineer. And to become a professional engineer after that 5-year period, you take another long test, and you kind of like bring a portfolio of all the projects that you've worked on, and you know, information about the engineers and companies you worked for. And it could be just one company, one engineer, or multiple, depending, who will vouch for what you've learned. And it goes before, you know, a state board, and then you can become a professional engineer. You know, they accept you with all that you've done to prove yourself. And after that, your signature's money. Then you can open up your own civil engineering firm and, you know, sign documents for projects that you've designed, and you wouldn't be putting your signature to it unless you knew that it would work. And you have like an official stamp that's registered through the state. And, you know, then you can work on all types of city, county, state related projects that you're hired to do. So the Texas one, and actually the hardest test, second hardest test, next to California, because in California, you have to really take into account the earthquakes that they have there. So they have a totally different added section that really not too many other places have to deal with. I mean, we deal with hurricanes, but I don't think it's in the wind and issues like that, but not as serious as, you know, the ground beneath your building and roads shaking everything apart. Here's our school. For those of you who maybe haven't been on campus, this is what the school looks like from above. It's a little bit different, as this was, I took this as soon as Google refreshed it, and they had just built it. So like about 8 to 9 years ago, this was just a field. That's all it was, just a field, nothing out there. Which means that whenever it rained, all the water just soaked into the ground. I think something like 40, maybe it's more, 40% of the water during a rainstorm tends to just infiltrate into the ground, soak into the ground like a sponge. Once the ground gets super saturated, then it starts to make the puddles that we see. One things that I did a lot as an engineer were subdivisions and drainage plans. And a drainage plan is trying to calculate how much water will be displaced during a large storm. Now, it seems like that might be something hard to do, but the math really is not more complicated than Algebra 1. There's just a lot of steps, a lot of charts, small equations to work with, put all together, things to look up on tables. It's got a lot of steps. But mathematically, it's nothing more complicated than Algebra 1. It was quite fun to mess with. And you calculate based off of whatever the city requires of you. So in Harlingen, they require that you, if you're going to build something new, that you're required to detain what's called a 5-year storm worth of water. Talking about a decent storm. 5 years roughly means like a storm probability intensity of every 5 years you might see this level storm. All the county drainage ditches that you see and those large ditches between the two counties over in Mercedes, that's designed, I think, for somewhere between a 40 to 50 year storm. So a fairly rare storm, maybe one that you would only see once in a lifetime. For reference, like Hurricane Harvey and Hurricane Katrina, those are acts of gods. They're like 500-year storm, like an act of God, like I said. You can't really prepare for that. That's why they evacuate the cities. And there are a few structures, like, for instance, during Hurricane Katrina, the Superdome, it was designed to withstand wind of that magnitude and was high enough in the ground to not be too worried about the flooding. There was some flooding issues and there were some leaking issues. It caught the engineers a little bit off guard, but it stood extremely strong and they used it as a shelter for those who hadn't evacuated. Anyways, so this is one of the things that I would do a lot. So in the front, there is a drainage ditch in the very front, highlighted here. Here's the bottom of it. Some might drive by to think it's a dry lake or something like that. It's designed to be dry. It's only supposed to be filled with water when there's a serious storm going by. So if you look, I'm trying to show it off on the screen here, but there's a little grate here. There's another one over here, and there's piping underneath there. In fact, it even comes down from the school. You can follow the pipes as you look at it, and you can see that as it goes, as the grates get closer and closer to that, they're deeper and deeper and deeper down into the grate because they're getting lower and lower because gravity is feeding them out that direction, out into this little riprap pipe exit. If you notice, you can even see kind of it's a different color in front of it. That's actually, they pour some larger gravel there, and that's to work with erosion so that you don't have it eroding the bottom of the dirt here and eventually getting water under the structure, which maybe over a decade would cause it to drop and crack the piping, and then water would get it under the street and cause some pretty serious, what's it called? Pits. When the ground starts cracking underneath it, is when the ground underneath it starts getting washed away. And just as an example of how simple it is, one of the things that engineers do is calculate the rise over run of the slope, so that those who are going to build it, they usually tell them like, oh, this slope here, this is like 1 to 6, meaning it's a foot drop 6 feet forward, rise over run, so that the contractors can put it in place. They don't give them like an angle or anything like that. They give it to them in rise or run form. Over here, we have a storm drain right on this side. There's another one here I didn't label. And the water goes, all the water from the parking lot goes down into this storm drain, which has a pipe which connects to this storm drain, which connects out to here. So all that water collected out here. There's another little inlet here that is just an open cut. So water just pours right through. Here's that rock that I was talking about. And the water just pours right in there. Let's see. This is the exit pipe right here. So we got 1, 2, 3, 4, 5 spots where water comes in, and this is where the water exits. It's the lowest point of this little pond, and the water is meant to be detained in here temporarily for a couple of days as the land starts to settle and water starts to continue to flow in underground passageways, underground water like aquifers and so forth. Then this starts to drain out, and it drains out under Lozano Street and goes out towards the canal over by those large cotton these things out here. So I actually took I actually drove around the school after it rained, like a real heavy, you know, how sometimes there's some really heavy storms that hit in the summer. So I'd actually come out to the school around that time and wanted to take pictures. Unfortunately, my car is way too low to the ground. So I had to wait like a day or two as it drained. Um, Here's a drainage ditch here, and then there's one actually behind the practice field. So this is what the front of it looks like. Before the street was flooded, I couldn't drive on it. So I got it after it was already starting to drain. It actually was, you know, as high as here and on the streets. We design our streets to be flooded before our buildings because it's okay if the street's underwater for a couple of days. It's not okay if water's going into your house for a couple of days. It's huge devastation. So behind the practice field, there's a little dip in the ground, and it just looks like it's another field, but it's actually designed to be a detention pond and hold water back in there. And in the back corners, there's a little inlets and outlets, if I remember right. And so there's a little ditch on the side here, connects back to this, and fills up with water when it rains and there's a pretty big hurricane coming.